Okay, pre-calc kids, this is day 4. Actually, we're going to do this in class, so the only one that really needs to watch it is Christian if he has some questions, or if any of you have questions. All right, so this is day 4, still section 1.2. And we're talking about how do we decide if a graph is a function. Now, it's all about the domain, okay? It's all about the domain. So remember, with a function, this is real important. Each x in the domain can have at most one y value, okay? So that's huge. And so if I look at this graph here, if I look at when x is 0, what's the y value? Well, here's 0, and the y value is 1. And when x is 1, what's the y value? Looks like still 1. When x is 2, looks like it's still 1. When x is 3, I'm going to go down from 3. Looks like it might be negative, what is that, 1 1/3 or something like that? Negative 1 1/3. It's hard to tell, just estimating. And when 4, my y value looks like negative 3, and when x is 6, looks like my y value is negative 1. So notice, do any of those x values have more than one y value? And no, when I do 8, I'm only going to go up to this point right here. There's no other point to go on. So if I do that, remember the vertical line test. Does that ring a bell to anybody? The vertical line test. You should be able to draw any vertical line that you want, and it should intersect the graph in at most one place. So there it intersected once, here it intersected once. So this passes the vertical line test because it only intersects it once. Notice the vertical line, if I had another one, like this next one, notice down here, when I draw a vertical line, the number negative 2 has 2 spots, right? Negative 3, can't even tell, 1, 2, negative 3, I guess, is here. It's got 2 spots. So this is not a function because you have more than one value for each x value. So that's not a function because of the vertical line test. So negative 3 looks like a positive 1 if I wanted to fill this in. Negative 3, negative, I can't even tell. I can't even read the numbers on the graph. I don't know why I put that in there. Anyway, so that doesn't work. So here it is, the vertical line test. It's used to decide if a graph is a function. If any vertical line is drawn, that line will only intersect the graph once. So you should be able to just look at these curves that I have here, even though you can't really see all the x and y values. You should be able to tell me if it's a function or not. So like here, I draw a vertical line. That's got 3, so that's not, right? A vertical line here, that's got 2, this is not. But this one here, any vertical line I draw, looks like it only intersects the graph once, so this is a function. Same way here, this next one, you've got any vertical line. Even if I do this one, notice it looks like there's an asymptote in there, but it doesn't matter, that's not part of the domain, and it only intersects once. So this is, this one, clearly not. This hyperbola, clearly not. This graph, I draw any vertical line. This is yes, it is. And this one, draw any vertical line. My lines aren't very vertical, sorry. Any vertical line. So this is yes, this is a function. Okay? So that's pretty simple. So now, when I look at can I determine what the domain is by looking at it? So remember, the domain are the x values, So if this is my function here, okay, that line there, I'm looking for the x values. Look at this red section down here where it says domain. What I like to do, I'm going to put my red pen on. What I like to do is, this is as far left as the graph goes. So what x value is that? And look, it's negative 4. Negative 4, that's the smallest x value. right? And over here, so it goes to this spot. Notice this y value, or this x value, my bad, is 3. So it goes between -4 and 3. But now look. This graph has a hole in it at 3. So we don't want to include it. But over here, it's got a solid dot. So we want to include it. So back in the day, we would probably have written it like this. X is greater than or equal to -4 and less than 3. Notice not equal to 3, but less than 3. So now we're doing it in interval notation. I don't know if you all did this last year, but we're going to use a square bracket when we want to include it, and we'll use a round bracket or a parenthesis if we don't want to include it. My college kids call these square brackets hard brackets, and the round brackets soft brackets. I don't care. I usually call them square and round. Okay, include, don't include. Okay, so that's my domain. So notice that's what's going. So that's the x value. So you're looking for the x value. So again, I did this to find the x value and this. That's what they did down here with this shading of red. So now if I look at my range, remember my range is the y value. So I'm going to change to blue because they did range in blue. Notice the lower blue is going to be here at 2, and the upper blue is here at 5. Okay, it's all about the y values. Where did the y values go? And notice over here, this was the open circle. So y -2, but I don't want to include, I'm sorry, +2, but I don't want to include it. And this y value was 5 that I want to include. So notice how they wrote that. They wrote it as 2. They don't want to include it, so it's a round bracket. And then 5, they want to include, so it was the square bracket. That's what these things mean here in small print that you can see on your graph, okay? So we're doing interval notation with this. Okay, so the same way here, I'll do the range first because I got my blue marker up. Okay, notice it starts down here at 0, right? That's the smallest. And then notice this is going to keep going up and up and up because of this arrow. So it's going to keep going up and up and up. It doesn't go up very fast, but it's going to keep going up and up. So we might have written the the range as y is greater than or equal to 0, right? Because it starts at 0. Now, do I include 0? Yes, it's a closed circle, so I'm going to include 0. So I would have a square bracket at 0, and now it's going to go to infinity. Okay, and infinities always have always have round brackets. Okay, so that's my range. My domain, if I look at the domain is the x values. Notice it's starting here at -4, and it's going on and on and on and on. Okay, so I want to include -4, so look what they wrote, -4 to infinity. Okay, we're going to practice that a bunch because that's super important that you get that. Okay? All right, so here, we'll do this one together real quick, and then I'll let you try some. So let's do domain. Domain. All right, that's the x values. So the smallest x value looks like it's here at -3, right? Do we want to include -3 is the question? And you say no, because there's an open circle there, right? So we don't want to include it. So we're going to have a soft bracket or a round bracket. And then what's the biggest? It looks like the biggest x value is here at 1. And do you want to include it? Yes, it's got a solid, so we're going to make it a square bracket. See, it's not so bad. And now if I do the range, the smallest range that I have, let me get rid of this stuff. The smallest range I have goes down to -4. So -4, and I'm going to include it because not only is the circle dot, but I'm pretty sure that that goes down to -4. So I'm going to include that. This is the range. And then what's the biggest y value? It looks like it's here. right? So to 0, that's that y value. Should I include it or not include it? Well, it's not included here, but I'm pretty sure it's included here. So as long as it's included once, we're going to put it as a square bracket. Okay? All right, last one. I guess I'll do this one too. So domain is the x value, so it looks like the smallest x value is negative 2 pi. This is domain. Negative 2 pi. And do I want to include it? Look, is it a solid circle? It is, so I'm going to put a square bracket. And the largest is positive 2 pi. And it looks like it's included, so I'm going to put a square bracket. And then for my range, the smallest value looks like it's negative 1. Range looks like it's negative 1. I'm pretty sure I should include that because this is a sine curve or a cosine curve, depending. And so I want to include that. And then the biggest y value looks like it's positive 1, and I'm going to include that as well. All right, good luck.